started recording.
Okay. So I'll just briefly again go through. I think you can see my screen now. Yeah.
Yes.
So what is going to happen is the conduction refers to the transfer of energy from the more energetic to less energetic particles of a substance due to interaction between the particles moving randomly. So the more energetic particles, which in this case are this, because this temperature is greater than this to T2, that is T1 is greater than T2, and hence energy of the particles at this phase, that is E1, is greater than E2, right? Yeah. So the more energetic particles would actually have the tendency to transfer the energy to a less energetic particle, right? Because of this interaction between them, and this is what is precisely known as conduction, right? Now in the right. Suppose a particle is at a higher temperature, which is this, then they naturally have a higher energy. That is, these molecules are of high energy, and they may experience collision. So because of the collision between these two molecules, let's say this molecule, this set of molecules with
Bharat,
this set of molecules. Hello.
Bharat, the top and the bottom walls are insulated, right?
Yes. We are always going to study, one day. This is one day system. Okay. Now due to the collision, these molecules are actually going to transfer heat, right, to those particles whose temperature is lesser than their temperature, right? Because of and that is what is called as conduction, right? Now in the presence of temperature gradients, what happens is the energy transfer must occur in the in the direction of decrease of temperature, right? So the direction of energy transfer, which in present case is this way, or let me, energy transfer occurs in this direction, right? So in a direction of the energy transfer is very important while quantifying heat transfer process, right? It is also important to recognize that there is temperature gradient, that there is a temperature gradient. The energy transfer must actually happen in the direction of decreasing temperature, right? So this is like T1 is greater than T2, that is why energy is going to happen, from left to right in this present case. Okay, right? What we have here is higher temperature, that means higher molecular energy, because of which higher collision frequency, or higher the number of collisions happening per second is going to be higher, and because of which energy is going to get transferred, right? Yeah. So in this various quantification process which we are going to study, which we will actually take into account the direction in which the heat transfer occurs, and that is actually crucial in quantifying the heat transfer process and the various methods that we will develop in this course. Okay. So this process of energy transfer that occurs in the direction of decrease in temperature is what is called as thermal diffusion, right? So this basically what I said, because of energy transfer, because of the mean movement of molecules, yeah, that is what is called as diffusion, thermal diffusion. Okay, that is what is going called as
सर
thermal
स्क्रीन शो
diffusion.
नहीं हो रही है सर.
Screen show नहीं हो रही है. Now you can see it. Screen. अभी देख सकते हो ना screen? Yes.
Now screen is visible, but now it's visible.
Right? Yeah. So this process of energy transfer that occurs in the direction of decrease in temperature is what is called as thermal diffusion. Right? So this is thermal diffusion. This is thermal diffusion. Very important. Mhm. Thermal diffusion. Right? Yeah, so the conduction or the thermal diffusion in liquids or solid typically occurs through molecular interaction. However, in a non-conducting material such as graphite or asbestos sheet, the typical transport occurs because of the lattice wave, right? So the heat transfer in conductors or good conductors happens because of the movement of electrons, right? And that is nothing but that is the major. Actually, it happens via both lattice wave as well as electron, but the contribution of translational motion of electrons in conductors happens is maximum because of this, whereas in non-conductors that is because of the lattice wave, right? However, in a non-conducting material, the typical transport occurs because of the lattice wave, right? The primary mechanism that governs the thermal diffusion in a non-conductor is lattice wave, right? In case of conductors, thermal diffusion is essentially governed by translation motion of electrons, right? So this is very clear. So basically what I'm trying to say is uh, conduction or thermal diffusion. Let me write it here. Thermal diffusion can occur via two parts, that is electron transfer, electron motion actually, and lattice waves, right? Plus this part is more for contribute highly for conductors, whereas this part contributes highly for non-conductors or insulators. Okay. So what different types of So for different types of material, the mechanism of thermal diffusion is actually different, and accordingly, the properties of this material are also different. Right. The next aspect which we are going to look into is how to quantify thermal diffusion process. Right. So quantification of thermal diffusion process. Now, in order to quantify, one needs to look at the rate expression. How does the transfer or the rate of heat transfer depend? What is the fundamental expression which governs this transfer of heat? So what we are going to develop is how to write the rate equation for these processes, right? So we are going to look at how are we going to write this rate expression. Okay. In particular, we are referring to how to estimate the heat transfer rate in a given system due to condition. Right? Suppose we want to estimate heat transfer rate for a particular system. Let's say consider a slab for which one phase is at temperature T1 and another phase is at temperature T2. Then what we need to have certain governing laws that connect the rate with the corresponding driving force, right? So we need to have expression like rate is going to be a function of what? Is going to be a function of driving force. Rate is going to be a function of driving force. Driving force. And it's also going to be dependent on resistance, right? So now what is this expression? What is this fundamental expression that we are going to need, in order to quantify this rate of heat transfer, right? And such a rate law is called as Fourier's heat law. Fourier's law, Fourier's heat law. And the Fourier's law essentially relates the flux of heat transfer with temperature gradient. Okay, so this is basically flux of heat transfer, and it's going to be dependent of negative of temperature gradient. Now, why this negative? That is because here we see that the energy transfer must occur in a direction of negative, in a direction of decreasing temperature. तो उसको counter करने के लिए, so that this flux becomes positive, we just add a negative thing. Okay. And remember the conventions which we are using. Whenever we have simple quantity, that is rate. This is Q prime is nothing but rate of heat transfer per unit area, and then flux of heat transfer is going to be heat transfer. Flux of heat transfer is rate divided by area, right? So we have, I think, yeah. So we'll the way these two are connected is like rate or rate is going to be area times flux. Okay, and rate is going to be length times heat transfer rate per unit length. Okay, so these are very important. This is also important. Okay, the Fourier's law of heat conduction. Okay, Fourier's law of heat transfer is basically what? Rate of heat transfer, flux of heat transfer is inverse is directly proportional to the negative of the temperature gradient. Okay, suppose we take a slab. Let's say this is an example which we are going to consider. Let's say we are taking a slab, and let us assume that it is cuboidal slab, and the cross sectional area of the cuboid is A. Okay, so this cross sectional area is A. Let me just draw here. It's a cuboid. Okay, and this area is going to be same as this area is going to be same as this area. Okay, so this is also A, and heat transfer is only occurring in this direction. Okay, so cross sectional temperature, the temperature across the cross section is going to remain constant. Okay, yeah, cross sectional area is A, and let us also assume that the temperature of one end of the slab is T1. So यहाँ पे temperature T1 है, यहाँ पे temperature T2 है, and T1 is greater than T2. Because of this, क्या होने वाला है? Heat is going to get transferred in this direction. Okay, and the temperature, yeah, this is temperature T2. So what will be the temperature profile? So we know that temperature at this point is T1 and temperature at this point is T2. Okay, but what is temperature, let's say, at this point? यहाँ पे टेम्परेचर क्या है? लेट्स से फॉर एग्जांपल इस इस क्रॉस सेक्शन पे टेम्परेचर क्या है? लेट्स से टोटल लेंथ है L, टोटल लेंथ है L, right? So in mathematical terms, what we are saying? We know that at x equal to 0, let's say this is 0 0 and this is 0 है. ठीक है, तो x equal to 0 टेम्परेचर इज T1. ठीक है, and at x equal to L temperature is T2, but let's say this is at a distance x. ठीक है, what is T at x equal to let's say x or x1? यहाँ पे टेम्परेचर क्या है? दैट इज व्हाट वी यहाँ पे टेम्परेचर क्या है? दैट इज व्हाट वी नीड टू फाइंड. सो हाउ विल यू डू इट? सो इन ऑर्डर टू कैलकुलेट दिस व्हाट वी नीड अ टेम्परेचर प्रोफाइल. अगर मुझे इस पूरे इसमें dt by dx पता है कि क्या टेम्परेचर ग्रेडियंट है, देन आई कैन फाइंड आउट व्हाट इज द टेम्परेचर at this particular any location. So what will be the temperature profile inside the slab? Can anybody tell? कोई बता सकता है? Can anybody tell what would be the temperature profile? कोई नहीं बता पाएगा. Temperature profile is going to be linear. तो temperature ऐसे vary होगा. It's going to vary like this. So this is temperature T2, like this, linear.
Bharat,
हाँ,
can you always make like some sort of symbol to show that the top there should not be any conduction from the top and the
so
bottom?
yeah, so we are we are considering always one dimensional heat conduction. So we have not yet touched
So just
what
make
is.
some sort of insulation on the top and the bottom one.
So you just show like this.
Maybe red color you can use.
See, pink I will use. ठीक है? This part is insulated. So it is going to get transferred in this direction only. Transfer. Okay? Actually, when I'm saying na this is the coordinate axis, that means, but okay, I will use a pink color. Okay. So now flux of heat transfer, flux of heat is given by minus k into dt by dx. Now from where this came? This came from here. जब तुम proportionality constant, when you get rid of this proportionality constant, you have to add when you have to get rid of this proportionality signature sign, you have to add equality and a constant, positive constant. And this equation you have to remember all the time. This is very important. And whenever I am saying this x, that means heat is going to get, the subscript basically denotes the direction of heat transfer. Whenever I am saying x, that means heat is going to get transferred along x direction, and this is the x direction here. Okay. So rate of heat transfer is nothing but area. Now what is this area? This is going to be the area. Orange one. This is the area. Actually, this area should also be ax. Okay. This area is ax. Okay. So rate of heat transfer is going to be area multiplied by flux of heat transfer, and flux of heat transfer is given by Fourier's law of heat conduction. This is nothing but Fourier's law of heat conduction. Okay. This is going to be minus k a into dt by dx. Okay. So from this, what we know, we see that. Okay. So Fourier's law basically says that the flux of heat transfer in x direction for this case is actually given by k into minus k into dt by dx, right? Which is, and this is nothing but the driving force. Dt by dx is driving force, right? Right. Okay. Now from this equation, we can clearly see that the rate of heat transfer, right? Rate of heat transfer is directly proportional to the area of the transfer. Larger the area, more will be the amount of heat getting transferred. Smaller is the area, lesser will be the amount of heat transfer. And it is also proportional to the driving force, right? This is the driving force. Higher the driving force, higher would be the amount of heat transferred. Similarly, vice versa. Okay. And we also note that q also is going to depend on k. Now what is this k? K is nothing but that proportionality constant, and we have a name for it. It is called as thermal conductivity, right? So this is different from thermal diffusivity, which we are going to study, right? Different from this is very important, thermal diffusivity study. We will see this later. Yeah, this is also very important to remember that thermal conductivity is very different from thermal diffusivity, right? Now note that this thermal conductivity is going to be the property of the material. As soon as I say this slab is made up of, let's say, gold or silver, so that thermal conductivity gets fixed, and all the other parameters they can change. However, thermal conductivity remains the same. So the moment the material is specified, then the thermal conductivity of that material is actually fixed. And thermal conductivity of that material is very specific to a given material, and it is an intrinsic property of the system, right? So this is nothing but intrinsic property. This thermal conductivity is an intrinsic property of a material. Okay. Now let us look at what the units of this, we say that this is the governing equation. This is going to be governing equation, and this is the proportionality constant. But what is its unit? This both units on the both LHS as well as RHS should match. Then only this equation has meaning, right? So now let us look at what is the unit, right? So the unit of what is this? This is flux, very important, always remember. I will be repeating this throughout the course so that you get used to it. ठीक है, so flux का यूनिट क्या रहेगा? एनर्जी पर यूनिट एरिया, ठीक है, और एनर्जी पर यूनिट एरिया, और एनर्जी क्या रहेगा? जूल पर सेकंड, दिस इज नथिंग बट जूल पर सेकंड, वैट मतलब जूल पर सेकंड, ठीक है. The unit of q prime, q double prime, that is nothing but flux, is going to be watts per meter square. Okay, they okay. So the इसका या इसका यूनिट रहेगा एक्चुअली, ये रहेगा वाट पर मीटर स्क्वायर, और ऐसे रहेगा, या दिस इज करेक्ट, वाट पर मीटर स्क्वायर, ठीक है. फ्लक्स का यूनिट रहेगा वाट पर मीटर स्क्वायर, रेट का यूनिट रहेगा वाट. ओके, रेट का यूनिट रहेगा वाट, वाट इज नथिंग बट जूल पर सेकंड. Right? Now we know that the heat transfer is given by Q is equals to minus K into area into dt by dx. तो Q का यूनिट है W, K का यूनिट वी डोंट नो, एरिया का यूनिट है मीटर स्क्वायर, और dt by dx इज नथिंग बट टेम्परेचर ग्रेडियंट, तो इसका रहेगा केल्विन पर मीटर. So when you take these units on the right hand side, you will find that unit of K, that is thermal conductivity, is nothing but watt per meter Kelvin. बेसिकली आएगा, जैसे फॉर एग्जांपल यहाँ से तुम देखोगे तो इट्स गोइंग टू बी यूनिट ऑफ के इज watt multiplied by meter square, okay, divided by k by m. Okay, और सॉरी इज गोइंग टू बी, k का यूनिट क्या रहेगा? watt, k का यूनिट रहेगा watt by meter square multiplied by meter by Kelvin. So unit of k is going to be watt per meter Kelvin, right, which is nothing but this. ठीक है, एंड रिमेंबर दैट दिस के, यहाँ पे हमने बोला कि क्यू एक्स इज ए एक्स इंटू क्यू प्राइम एक्स, मतलब क्यू एक्स इज नथिंग बट के इंटू ए इंटू डी टी बाई डी एक्स. नाउ एज सुन एज ऐसे दिस इज इन एक्स डायरेक्शन, ये के भी होगा के एक्स एक्चुअली. क्यू एक्स इज नथिंग बट ए एक्स इंटू क्यू एक्स डबल प्राइम विच इज माइनस के एक्स ए एक्स इंटू डी टी बाई डी एक्स. राइट, सो ये सब एक्स डायरेक्शन में चल रहा है. तो देर इज नो रीजन एज टू वाई, यू नो, जैसे एक्स डायरेक्शन में है वैसे वाई डायरेक्शन में भी होगा. राइट, जैसे एक्स डायरेक्शन में है क्यू प्राइम इज माइनस, नो, जैसे एक्स डायरेक्शन में है दिस इज एक्स डायरेक्शन, वैसे ही वाई डायरेक्शन में होगा, वैसे ही जेड डायरेक्शन में होगा. ओके, तो टेम्परेचर ग्रेडियंट भी तुम्हारा एक्स डायरेक्शन में होगा, टेम्परेचर ग्रेडियंट भी वाई डायरेक्शन में होगा, टेम्परेचर ग्रेडियंट भी जेड डायरेक्शन में होगा. तो दीज आर ऑल डिफरेंट. सो बेसिकली व्हाट आई एम ट्राइंग टू से इज कि we know that qx is minus kx ax into dt by dx. ठीक है, सिमिलरली आएगा qy which is minus ky ay dt by dy, और qz आएगा minus kz az dt by dz. राइट, इसलिए अगर मैं इसको वेक्टर नोटेशन में लिखूंगा, so the way to write this in okay, in vector notation is this. ठीक है, q डैश इज इक्वल्स टू माइनस के इंटू लैप्लास ट्रांसफॉर्म ऑफ टेम्परेचर, और यू नो डेल टी, इसको बोलते हैं डेल टी. सो दिस वुड बी, this notation I think would be covered extensively and used extensively in your fluid mechanics course which Shreyank is taking. Now the way you expand it is minus k, so actually हो जाएगा ये q prime is del t which is nothing but minus kx into ax, oh sorry not ax, minus kx into del t by del x I cap, right, minus ky into del t by del y j cap minus kz into del t by del z of k cap. Right, so when the material is isotropic, it is isotropic. इसका मतलब क्या है? आइसोट्रोपिक का मतलब ये होता है कि के एक्स इज इक्वल टू के वाई इज इक्वल टू के जेड, मतलब थर्मल कंडक्टिविटी हर डायरेक्शन में सेम है. ओके, इन दैट केस व्हाट वी कैन डू इज वी कैन टेक दिस के आउट, ये के आउट बाहर निकाल लेंगे. सो इन दैट वे ये एक्सप्रेशन हो जाएगा ऐसे, क्यू प्राइम इज इक्वल टू माइनस के डेल टी बाई डी एक्स विच इज नथिंग बट माइनस के इंटू डेल टी बाई डेल एक्स आई कैप plus del t by del y j cap plus del t by del z k cap, right? Which is nothing but minus k into qx double prime, qy double prime, and qz double prime. qx double prime क्या है? Heat transfer flux in x direction. qy double prime heat transfer flux in y direction, and qz prime is heat transfer flux in z direction. ठीक है? And temperature, here you see we are writing partial derivatives. Temperature of the partial derivative of temperature with respect to x, with respect to y, with respect to z. इसका मतलब हमारा जो टेम्परेचर है that is nothing but a function of x coordinate, y coordinate, and z coordinate of the system. ठीक है? This is actually isotropic system. This is isotropic system. ठीक है? For non-isotropic system, all the case are going to be different. ठीक है? ये समझ गया ना सबको? Anybody has any doubt in this? ये इक्वेशन में, इस एक्सप्रेशन में किसी को कुछ डाउट है?
No,
है क्या
sir.
किसी को? नो ना रे, थैंक्स, थैंक यू. ठीक है, ठीक है, या. So now let us look at the next slide, which is thermal conductivity. So what is the order of relation between thermal conductivity of solid, thermal conductivity of gas, and thermal conductivity of liquid, right? So it just so happens that thermal conductivity is a property that essentially captures the ability of a system to actually conduct it. तो ये बहुत important है. Add कीजिए. So thermal conductivity is a property that essentially captures the ability of the material substance to actually conduct heat. ठीक है? So higher the K, higher the ability to conduct or transfer heat. इसका मतलब क्या है? इसका मतलब ये है कि जो भी लेट्स से 10 क्वांटा ऑफ एनर्जी इज कमिंग और 10 जूल ऑफ एनर्जी इज कमिंग टू दैट मटेरियल, इट इज ट्रांसफरिंग लेट्स से 10 जूल ऑफ एनर्जी. इसका मतलब क्या है? द एबिलिटी ऑफ दैट मटेरियल टू स्टोर द हीट इज वेरी लेस. ठीक है? मतलब हायर द के, हायर द एबिलिटी ऑफ मटेरियल टू ट्रांसफर हीट, that means lower is the ability of that material to store heat. और ये क्या होता है? ability of material to store heat is what? That is nothing but CP, specific heat capacity. ठीक है? That means lower the CP value. Just a intuitive understanding what we can do. ठीक है? Yeah. So one may ask question as to why there is difference, in thermal conductivities. Oh, sorry, thermal conductivity. Yeah. So we said that thermal conductivity is the ability of material to conduct heat or transfer heat. Conduct की जगह transfer. The transfer will be that. So thermal conductivity of solid. Yeah. So thermal conductivity of solid is generally higher than that of liquid, which is again higher than that of gas. To have a sense of numbers, the thermal conductivity of gas is typically, in the order of 0.01 to 1 watt per meter Kelvin, whereas thermal conductivity of liquid is around 0.225 watt per meter Kelvin, and that of solid is very high. So there is an order of magnitude difference between thermal conductivity of solid and liquid and gas also. Now one may ask a question as to why there is a difference in the thermal conductivity across different types of material. Why thermal conductivity of solid is high? Why thermal conductivity of gas is least? Yeah. Well, what could be the reason for this? Yeah, would anybody like to answer this? Anybody would like to answer this? इसका
The
देखो यहाँ
gap
पे
between the constituents of particles of solid and gases.
yeah, yes, that is one of the reason कि जो solid molecules होता है they are very closely packed together, उसकी वजह से they cannot move, you know, that much, whereas in liquids they are relatively further apart and hence their motion is independent, and gas में तो एकदम ही independent होता है, right? So remember that earlier we said that thermal conductivity of any material has two parts: thermal conductivity because of free electrons and thermal conductivity because of lattice wave. ठीक है? Now for metals, when we say metal मतलब solid, good conductors, उनमें higher free electron contribution of thermal conductivity by free electrons is much higher because they are very closely packed, right? Because of this effect to thermal conductivity of solid, we can say that it's nothing but very close to thermal conductivity of electrons, motion of free electrons. Okay, and this is very high, right? And the inverse of this thermal conductivity or thermal conductivity is nothing but electrical resistivity. Okay, for non-metals this contribution of lattice wave is very high as compared to that of free electrons, right? इसकी वजह से liquid or solid, liquid or gas का thermal conductivity is very less as compared to that of solids. ठीक है? And that is why this is the reason as to why the thermal conductivity of solid is much higher than that of liquids or gases. ठीक है? किसी को कोई क्वेश्चन?
Oh, sir.
Okay, yeah, like I said, particles are very random, that is why their thermal conductivity is less, whereas for gas it is even less, and it is also dependent on the temperature and pressure. Now why? Because volume, volume is going to be, for gases volume is a function of pvt, बराबर ना? फॉर गैस के लिए क्या होता है? आइडियल इक्वेशन ऑफ स्टेट होता है ना? फॉर गैस के लिए वॉल्यूम इज नथिंग बट फंक्शन ऑफ पीटी, राइट? बिकॉज ऑफ विच क्या होगा? वॉल्यूम इज अ फंक्शन है, मतलब द गैप बिटवीन द मॉलिक्यूल्स इज अ फंक्शन ऑफ प्रेशर एंड टेम्परेचर, इसलिए thermal conductivity of gas is also a function of temperature and pressure, right? So the typical expression for that is thermal conductivity of gas is directly proportional to the number of molecules. So n is number of molecules, c bar is relative speed of molecule, relative velocity of molecule, and lambda is mean free path. ठीक है? Because of this reason k gas or thermal conductivity of gas is function of number of molecules, relative velocity of the molecules, and thermal conductivity of a molecule. ठीक है? Okay, now recall that conduction occurs to the process of energy transfer in the direction of decreasing temperature, right, which is called as thermal diffusion, right? So now here we are defining one other quantity called as thermal diffusivity, right? I initially also I said that thermal diffusivity is very different than thermal conductivity. This point has to be very remember that thermal conductivity or diffusivity is different from thermal conductivity. तो थर्मल डिफ्यूजिविटी जो होता है उसका फॉर्मूला है ये k by rho cp, right? Which where k is thermal conductivity, rho is density, and cp is the heat capacity. So now what does this explain? I said earlier that thermal conductivity is nothing but ability of material to transfer heat, whereas rho cp is what here we mentioned, right? Somewhere we mentioned. Where is it? Yeah, कहाँ पे लिखा है? Yeah, k मतलब higher the ability of material to transfer heat, whereas Cp is what? Ability of that material to store heat. So let's say ये एक this is a some example, some geometry. यहाँ पे टेम्परेचर T1 है, यहाँ पे टेम्परेचर T2 है. तो यहाँ से यहाँ जब हीट ट्रांसफर हो रहा है, तो लेट्स से इस क्रॉस सेक्शन पे या सम क्रॉस सेक्शन पे the heat has two option. The material has two option of diffusing that heat. Either it can store heat in itself and increase its temperature, or it can transfer heat across this surface area to the next surface area. तो ये जो है thermal diffusivity is nothing but a ratio of that. So this is nothing but ability of material to store heat, to conduct it, divided by ability of material to store heat. Right? This is very important. ये very important. That is thermal diffusivity is nothing but, let me write, thermal diffusivity which is nothing but alpha is ability of material to transfer heat divided by ability of material to store heat. So ability of material to transfer heat क्या? K divided by rho Cp, right? So here I said it is actually Cp only, but to make it dimensionally consistent, we are adding rho. तो इसका dimension देख लेते हैं एक बार. What is the dimension of this alpha? This is nothing but thermal diffusivity का dimension we know that it's watt per meter Kelvin. This one density का dimension kg per meter cube और heat capacity का dimension joule per kg Kelvin. Right? So when you do the math, balance about remove this. Let's say joule के साथ cancel हो गया, kg के साथ cancel हो गया, meter के साथ cancel हो गया. So when you do, you find that the unit of thermal diffusivity comes out to be meter square per second. ये दिस इज वेरी इंपॉर्टेंट. जैसे ये है थर्मल डिफ्यूजिविटी, वैसे ही मास ट्रांसफर में तुम लोग पढ़ोगे देयर इज समथिंग कॉल्ड एज मास ट्रांसफर डिफ्यूजिविटी. उसको डी से डिनोट करते हैं. उसका भी यूनिट इज गोइंग टू बी मीटर स्क्वायर पर सेकेंड. राइट? वैसे तुम फ्लूइड मैकेनिक्स में पढ़ोगे देयर इज समथिंग कॉल्ड एज मोमेंटम डिफ्यूजिविटी. उसका भी यूनिट मीटर स्क्वायर पर सेकेंड ही होता है. राइट? सो दिस इज वेरी, so this this is one way of saying that heat transfer, mass transfer and momentum transfer, these are all connected phenomena. From here you can see. Okay. Yeah. So again I have written here alpha is nothing but ability of material to conduct thermal energy relative to its ability to store heat. Right? To conduct thermal energy, to conduct the thermal energy. Okay. किसी को कुछ डाउट इसमें? या नो डाउट?
No,
No,
sir.
sir.
तो इसका अभी तक हमने क्या सुना? हमने देखा कि this is what rate of heat transfer, this is what rate per unit length. Oh, let me write in blue page. Summary till now. Summary. ठीक है? That this is nothing but rate of heat transfer. This is rate of heat transfer per unit length. This is flux of heat transfer, and they are going to be related as Q is nothing but Q flux multiplied by, sorry, okay, and rate of heat transfer is nothing but minus Ka dt by dx. ये है Fourier's law of heat conduction. ठीक है? Then rate Q is nothing but, or right, this is nothing but Q by L, and flux is nothing but Q by A. Okay, and then Q is nothing but Qx prime I cap, Qy double prime K cap, Qz double prime, sorry, this is J cap, Qz double prime K cap. ठीक है, where Qx or Qi, where I is equals to x y z is nothing but minus Ki Ai into dou t by dou I. ठीक है, इन वेक्टर नोटेशन हम इसको बोल सकते हैं del t. ठीक है, and then we also studied thermal conductivity and thermal diffusivity, which is nothing but K by rho Cp. इसका यूनिट है मीटर स्क्वायर पर सेकेंड. ठीक है, now with this definition we will start at looking at how to write heat balances in order to estimate or find the temperature distribution in the system. ठीक है, तो ऐसा करेंगे. Okay, so we are going to go deeper in now onwards into today and look at how to quantify heat transfer. Okay, so we will take certain examples and we can look at the quantification process. यहाँ पे हमने कैसे किया, यहाँ पे तो हमने बस बोला कि this is the law, ये ऐसा ये करते हैं, but actually what is the distribution? Can we visualize the distribution? How do we quantify heat transfer? What is the actual amount of heat transfer, which is heat which is getting transferred, so on and so forth. Okay, so we are going to try to understand this using next some questions. Now in general, if I ask you, in order to quantify the heat system, what we actually need, we actually need to know, if we know the distribution. Now when I say distribution, that is nothing but derivative of temperature with respect to length. मतलब dt by dx अगर हमको पता है तो हम उसको उस इक्वेशन को इंटीग्रेट करके टेम्परेचर भी निकाल सकते हैं, और उसके बाद फ्लक्स तो हमको पता ही है, फ्लक्स इज नथिंग बट k इंटू a इंटू dt by dx, फ्लक्स इज k इंटू dt by dx. तो अगर हमको dt by dx, if we know that derivative, or if we know that term dt by dx, how temperature is relating with respect to a position, then we can find temperature भी निकाल सकते हैं. Temperature is going to be nothing but integration of dt by dx with respect to x, and then flux is nothing but minus k into dt by dx, right? So we can flux, और एक बार flux हमको पता चल गया तो area by multiplying it with area we can quantify heat transfer also, the rate of heat transfer, right? So basically what we need to find मतलब प्रॉब्लम का जड़ है कि अगर हमको dt by dx पता है तो in principle we can find everything, right? That is what is called as temperature distribution. dt by dx को बोलते हैं temperature distribution. Now for finding the temperature distribution we need to write energy balance. ठीक है, कि कितना अमाउंट ऑफ एनर्जी आ रहा है, कितना अमाउंट ऑफ एनर्जी जा रहा है, कितना हीट ट्रांसफर हो रहा है, सो ऑन एंड सो फोर्थ. सो लेट अस टेक, जैसे यहाँ पे हीट ट्रांसफर बनने से दैट वी नीड टू नो डिस्ट्रीब्यूशन फॉर टेम्परेचर. एक्स का भी पोजीशन फंक्शन हो सकता है, वाई का भी हो सकता है, जेड का भी हो सकता है, टेम्परेचर का भी हो सकता है. नाउ इफ वी नो दिस पार्शियल डेरिवेटिव, we know what is flux, and once we know flux we can just calculate what is transport rate by multiplying with respect to area. Okay, I think somebody's mic is on. Radhika. Yeah, thank you. Radhika, your mic is again on. Yeah, thank you. ठीक है, so now अब हमको क्या करना है, we need to do energy balance. Now let us try to do energy balance on एक कोई भी रैंडम सा शेप का मटेरियल लेते. दिस इज लेट्स से क्यूबॉइडल एक मटेरियल लिया, और हम फॉर फाइंडिंग द टेम्परेचर डिस्ट्रीब्यूशन वी नीड टू राइट द एनर्जी बैलेंस. ओके, सो नाउ लेट अस टेक दिस क्यूबॉइडल मटेरियल जिसका लेंथ इन एक्स डायरेक्शन, सो दिस इज द कोऑर्डिनेट एक्सिस. सो यहाँ पे हम बोल रहे हैं कि जैसे फॉर दिस इनिशियल केस वी सेड दैट हीट इज ट्रांसफरिंग ओनली इन वन डायरेक्शन. यहाँ पे जैसे हमने बोला कि एक ही डायरेक्शन में, तो वी आर रिलैक्सिंग दिस असम्पशन. वी आर नॉट सेइंग दैट हीट इज ओनली वन डायमेंशनल, इट कैन गेट ट्रांसफर्ड इन एनी डायरेक्शन. ठीक है, तो इसलिए इस क्यूबॉइडल एलिमेंट लिया, उसमें हमने these are the coordinate axis. The red color is x direction, black color is y direction, and this orange color is z direction. So the length of this arbitrary element. In x direction is delta x, in y direction it is delta y, and in z direction it is delta z. ठीक है. So now there are cuboid है, तो cuboid के 6 surface हो गए, right? So this is one surface, this is second surface, this is third surface, this is fourth surface, and then this is fifth, and this is sixth surface. Okay, so let us assume that at x equal to 0, or let's say at x equal to x, so this position is x, and this is going to be, oh sorry, yeah, so this position is going to be at x equal to x, and this position is going to be at x equals to x plus delta x. ठीक है, x plus delta x. Similarly, ये जो position है, this is z equal to z, and this position is z is equal to z per delta z, and this position, this is y equal to 0, and this is sorry, this is y equal to y, and this is y equal to y plus delta z. So what is the amount of heat which is coming to this surface? ठीक है, तो इस सरफेस पे जो हीट आ रही है दैट इज qx. ठीक है, तो यहाँ से आएगी तो यहाँ से जाएगी. ठीक है, एंड द अमाउंट ऑफ हीट विच इज गोइंग अवे और लीविंग दिस सरफेस इज लेट्स से qx plus delta x. ठीक है, similarly amount of heat which is going to come at this surface is qy, and which is going to leave this surface is q of y plus delta y. Similar would be for z. इस सरफेस पे जो हीट आएगी दैट इज qz, और इस सरफेस से जो निकलेगी दैट इज qz plus delta z. तो अभी हमको बैलेंस लिखना है कि व्हाट, एंड लेट्स से q इज द अमाउंट ऑफ हीट, q डॉट इज द वॉल्यूमेट्रिक रेट ऑफ हीट जनरेशन. लेट्स से यहाँ पे हमने कुछ let's say this is electrical heater लगा दिया. Let's say this is filled with water and we are putting electric heater. Now because of the volume is q dot. तो अगर हमको बैलेंस लिखना है तो the way we would write the balance is what is the total amount of input which is coming into the system. When I say system, that means this full cuboidal element. So input minus output plus whatever has been generated, that should be equal to accumulation, right? And accumulation is nothing but the amount of energy stored in the system, right? Whenever the moment I say कि stored, तो हमको पता है कि store, अब ability of a system to store में cp की वैल्यू आनी चाहिए. ठीक है, ये cp की वैल्यू आनी चाहिए, तो कहीं ना कहीं यहाँ पे accumulation term में cp आना चाहिए. So this we know a priori, right? And the convention which we are going to use is when heat is generated into the system, we are going to say that it's positive, and when it is dissipated or it's removed from the system, we are going to say it's negative, right? Now what is the input to the system? What is the rate of or the heat input to the system? Heat input is at this phase, then at this phase, and at this phase. Okay, so input is nothing but heat flowing in at phases x equal to x, y equal to y, and z equal to z, right? That is why input is nothing but qx plus qy plus qz. And always remember there are no primes in here. मतलब यहाँ पे कुछ है नहीं, जैसे ये नहीं है, ऐसा कुछ है नहीं, या डबल कुछ नहीं है, तो इसका मतलब ये हम रेट पे बैलेंस कर रहे हैं. वी आर बैलेंसिंग ऑन रेट. Okay, now what is the output? Output to the system is heat flowing out at phases x plus delta x, which is which is this x plus delta x, y plus delta y, and z plus delta z. ठीक है, so this is the total amount of heat output. ठीक है, what is the generation? Generation is nothing but we said that it's q dot. Q dot is the rate of heat generation per unit volume. तो इसका जो है वॉल्यूमेट्रिक हीट जनरेशन, इसलिए इसको अगर मेरे को रेट पे कन्वर्ट करना है, इसका यूनिट क्या होगा? वैट पर मीटर क्यूब. इसका यूनिट क्या है? वैट. इसका यूनिट क्या है? वैट, बिकॉज दिस इज रेट, राइट? सो यूनिट बैलेंस इज वेरी इंपॉर्टेंट, राइट? आई थिंक आई शुड यूज डिफरेंट कलर. इसका यूनिट है, यूनिट इज वैट, because this is rate of heat transfer इसका भी यूनिट है वैट, बिकॉज दिस इज रेट ऑफ हीट ट्रांसफर। ठीक है, इसका जो यूनिट है, इसका यूनिट है वैट पर मीटर क्यूब। नाउ वी नीड टू मल्टीप्लाई इट बाय मीटर क्यूब टू मेक इट इन द यूनिट्स ऑफ रेट, इसलिए हम इसको वॉल्यूम से मल्टीप्लाई कर रहे हैं। दिस इज नथिंग बट वॉल्यूम, वॉल्यूम ऑफ द डिफरेंशियल एलिमेंट। ठीक है, and then what is the accumulation? Accumulation is going to be rho into cp into dt by dx. So rho into cp क्या होगा? Rho is nothing but kg per meter cube, cp का क्या है? जूल पर kg केल्विन, right? And dt by dx is rate of change of temperature with respect to time. Okay, so actually the way you should look at it is ये जो rho multiplied by volume, तो इसको ऐसे देखो तुम कि rho multiplied by delta x delta y delta z multiplied by cp into dt by dt। तो ये क्या है? सॉरी, ये क्या है? दिस इज डेंसिटी मल्टीप्लाइड बाय वॉल्यूम, मतलब ये क्या है? मास। इसेंशियली दिस इज नथिंग बट मास। सो m cp, m into cp into dt by dt, right? This is the ability of material to store heat, that is accumulation। टोटल हीट बैलेंस क्या था हमारा? इन माइनस आउट प्लस जनरेशन इज इक्वल टू एक्यूमुलेशन। इन इज दिस, ठीक है, क्यू एक्स प्लस क्यू वाई प्लस क्यू जेड। जो आ गया यहाँ पे क्यू एक्स प्लस क्यू वाई प्लस क्यू जेड। व्हाट इज आउट? आउट इज दिस, राइट? तो हमने यहाँ पे लिख दिया माइनस क्यू एक्स प्लस डेल्टा एक्स, क्यू वाई वाई प्लस डेल्टा वाई, जेड प्लस डेल्टा जेड। देन व्हाट इज द हीट जनरेशन? हीट जनरेशन इज दिस, तो ये लिख दिया हीट जनरेशन विच इज नथिंग बट रो cp by dt by dt। so convince yourself, this is the homework, you can try, if you are not able to understand कि इस सब का यूनिट जो है, इस सब का यूनिट इज गोइंग टू बी वैट। I should use a unit is watt or joule per second। ठीक है, this you try to convince yourself। now what we are going to see is we are going to collect the similar terms, जैसे qx है qx plus delta x, qy plus delta y, qz and qz plus delta z। इसको एक कलेक्ट किया, right? now why we are going to do is we are this is a general element, right? तो हम ये delta x delta y delta z है, ये this is very less, right? so in order to do it हम क्या करेंगे? उसका लिमिट लेंगे, लिमिट delta x टेंडिंग टू 0। और बिफोर दैट, प्रायर टू दैट, हम इसको वॉल्यूम से मल्टीप्लाई डिवाइड करेंगे, डिवाइडिंग बोथ द साइड्स बाय वॉल्यूम, right? so then it becomes like this, and then we are going to take limit, right? और इसको सिमिलर टर्म्स को, दिस इज व्हाट you know by the definition of function की limit x tending to 0 f of x plus h minus f of x divided by x is what? Derivative of f with respect to x। so this somehow correlates to this when we take limit, right? तो ये क्या है? डेल्टा वाई डेल्टा जेड इज व्हाट? ट्राई टू इमेजिन हियर। तो लेट्स से ये फेस है हमारा, तो इसका ये क्या है? दिस इज नथिंग बट डेल्टा जेड, और ये क्या है? डेल्टा वाई। अगर तुम ये सरफेस लोगे तो ये क्या है? डेल्टा एक्स, ये क्या है? डेल्टा वाई। सो बेसिकली यहाँ पे तुम आओगे तो दिस इज नथिंग बट एरिया परपेंडिकुलर टू दी एक्स डायरेक्शन, राइट? ये वाला एरिया है बेसिकली, ये वाला, ठीक है? दिस इज डेल्टा वाई, दिस इज डेल्टा एक्स, ठीक है? तो डेल्टा वाई इंटू डेल्टा जेड इज यूनिफॉर्म क्रॉस सेक्शनल एरिया इन एक्स डायरेक्शन, डेल्टा एक्स डेल्टा जेड इज यूनिफॉर्म क्रॉस सेक्शनल एरिया इन वाई डायरेक्शन, एंड डेल्टा एक्स डेल्टा वाई इज यूनिफॉर्म क्रॉस सेक्शनल एरिया इन जेड डायरेक्शन, राइट? सो दिस इज व्हाट द एक्सप्रेशन वी गॉट, और उसके बाद हम इसको लिमिट लेंगे, इसका लिमिट लेंगे, because the differential element we want to make it very small so that the equation which we are going to derive it would be general in nature, ठीक है? तो ये क्या आ गया? देखो, रिमेंबर आई सेड दैट f of x plus h minus fx is x, if ये d by dx है, df by dx, ये तो उल्टा है, so there should be a negative sign here। तो इसलिए जब तुम इसको डेरिवेटिव में कन्वर्ट करोगे तो यहाँ पे नेगेटिव साइन आएगा, राइट? so now remember this is rate, ठीक है, रिमेंबर दीज आर द रेट ऑफ हीट ट्रांसफर एंड दीज आर नॉट द फ्लक्स. नाउ इफ वी वांट टू फाइंड दी, हमारा एम क्या था, एम हमारा था कि टेम्परेचर डिस्ट्रीब्यूशन निकालना है, हमको dt/dx की वैल्यू निकालना है. बट हमारा यहाँ पे क्या आया, हमारा आया del Q/del x, del Q/del y, del Q/z, del Q/del z. Now if we want to find dt/dx or the derivative of temperature with respect to position, somehow we need to replace these terms so that their dt/dx comes. ये क्या है, वो आएगा हमारा कॉन्स्टिट्यूटिव रिलेशनशिप विच इज नथिंग बट हमारा फोरियर्स लॉ ऑफ हीट कंडक्शन. फोरियर्स लॉ क्या बोलता है कि रेट इज नथिंग बट एरिया मल्टीप्लाइड बाय फ्लक्स विच इज नथिंग बट द एरिया परपेंडिकुलर टू द फ्लो multiplied by the thermal conductivity and the temperature gradient, right? So qx is nothing but, let's say this is the direction of qx, right? ये qx है, तो qx की वजह से जो हीट ट्रांसफर होगा, और qx इज द रेट ऑफ हीट ट्रांसफर इन x डायरेक्शन, वो किसकी वजह से होगा, वो होगा टेम्परेचर डिफरेंस अलोंग द x डायरेक्शन मल्टीप्लाइड बाय द एरिया परपेंडिकुलर टू x डायरेक्शन, जो कि है ये, राइट, एंड मल्टीप्लाइड बाय थर्मल कंडक्टिविटी इन x डायरेक्शन, राइट. सिमिलरली y के लिए क्या होगा, लेट्स से ये y है, तो दिस एरिया ये क्या है, डेल्टा z इंटू डेल्टा x मल्टीप्लाइड बाय k इन दिस डायरेक्शन multiplied by the temperature derivative in this direction, that is dt/dy. ठीक है, तो इसको हम qx को ऐसे लिख सकते हैं, qy को ऐसे लिख सकते हैं, और qz को हम ऐसे लिख सकते हैं. Now for isotropic, so remember this is kx, ky, kz. So what we are going to, this is very important, right? Now for isotropic system, we already know कि kx is nothing but ky, which is nothing but equal to kz. This should be z. ठीक है, लेट्स से दिस इज k, तो हमारा अगेन इक्वेशन जो है और सिंप्लीफाई हो गया, माइनस k इंटू दिस एरिया मल्टीप्लाइड बाय dt/dx. नाउ लेट्स से दिस इज, लेट्स कॉल दिस एज इक्वेशन 2 एंड दिस इज इक्वेशन 1. अब इसमें qx को डालो, so let us write in x डायरेक्शन. तो जैसे ये एक्सप्रेशन है, बस इसी को अभी देख रहे हैं कि हाउ वी आर गोइंग टू सॉल्व इट, राइट. सो दिस इज नथिंग बट दिस माइनस के dou/dou x ऑफ qx की वैल्यू क्या है, ये, तो बस ये डाल दिया मल्टीप्लाइड बाय दिस थिंग. सो नाउ द एरिया गेट्स कैंसल्ड आउट. So finally what we get is this value k into d2t/dx², right? Remember that delta y and delta z is constant area. ये जो है ये एरिया कांस्टेंट है, रिमेंबर. भले ही हमने डेल्टा y और डेल्टा z लिया है, बट दिस एरिया इज कांस्टेंट. क्या एरिया हमने कांस्टेंट लिया है. तो ये जो इक्वेशन हम डिराइव करेंगे, राइट. Similarly, we can also write like this, and then when we put this into the original equation, the final equation which we get is this: k into dou t by dou x square plus dou t by dou y square plus dou t by dou z square plus rate of heat, volumetric rate of heat generation is nothing but rho cp dt by dx, right? और इसको अगर हम वो करेंगे, if we do take k common and do some manipulation, divide everything by k, so here we get that thermal diffusivity 1 by alpha, right? So यहाँ से आता है, so this is ability of material to store heat divided by ability of material to conduct heat, right? So this is the overall equation which is very very important. ठीक है, dou 2t by dou x square plus dou 2t by dou y square plus dou 2t by dou z square plus q dot by k is equals to 1 by alpha dou t by dou t. Okay, so this is the expression in vector notation. You can write this like this: dou 2t plus q dot by k is equal to 1 by alpha. Now two things which are very important is limitation of this equation. Okay, we are assuming that the system is isotropic, that is kx is equals to ky is equals to kz, and number two, area is constant. ठीक है, मतलब लेट्स से फॉर एग्जांपल, जैसे ये है, ये इस this is a cylinder of uniform cross section area, so for this is applicable, we can apply this. However, अगर हमारा एरिया ऐसा है फ्रस्टम ऑफ कोन जैसा, like this, then we cannot use this expression. These are the two limitation of this expression. right? So ये क्या है? These are basic. So this is basically partial derivative, right? Partial derivative. To a second order partial derivative equation, right? दो t है, तो इसको सॉल्व करने के लिए हमें क्या चाहिए? दिस इज नथिंग बट लाइक दिस, राइट? ये ऐसा है। तो इसको सॉल्व करने के लिए हमको क्या चाहिए? हमको चाहिए एक इनिशियल कंडीशन कि टेम्परेचर एट टाइम t इज इक्वल टू 0 क्या है, एंड वी नीड टू बाउंड्री कंडीशन टू डिफाइन व्हाट इज यू नो टेम्परेचर एट two boundary conditions we need, right? So we need boundary condition to solve this equation, okay, to get temperature profile. And once we get the temperature profile, we can calculate the rate of heat transfer. Now what are the different types of boundary condition? The constant boundary condition. One type of boundary condition is constant boundary condition. Heat temperature at, let's say, some position is nothing but same, is well defined, Ts. Like for this example, you can consider that this is a slab. The temperature at x equal to 0 is T1, and temperature at x equal to L is T2. So this is one type of boundary condition. Another type of boundary condition is flux, constant flux boundary condition. कि at this surface, let's say, या इस surface पे insulated है. Insulated है इसका मतलब flux of heat transfer is zero. मतलब यहाँ से कोई heat transfer हो नहीं रहा है. So flux of heat transfer is zero, मतलब rate of heat transfer is also zero. Right? So this is a constant flux boundary condition. Then उसका ही दूसरा पार्ट है कि constant flux तो है, जैसे ये जीरो है लेकिन constant flux है but some value. मतलब यहाँ पे क्या था कि यहाँ पे insulated था तो flux is zero. मतलब वो जो कांस्टेंट था उसका वैल्यू जीरो था, वेयर एज हियर द कांस्टेंट वैल्यू कुड बी समथिंग, लाइक जैसे यहाँ पे कांस्टेंट वैल्यू इज जीरो, वेयर एज यहाँ पे कांस्टेंट वैल्यू कुछ है. दिस इज अ स्लैब एंड सराउंडिंग इट इज अ फ्लूइड, लेट्स से वाटर. तो यहाँ पे फ्लक्स है, इस पॉली पे फ्लक्स इज नथिंग बट सम कांस्टेंट क्वांटिटी, लेट्स से दिस इज 10, लेट्स से दिस इज 100. यहाँ पे 100, यहाँ पे 0. ओके, एंड देन वेरिएबल फ्लक्स बाउंड्री कंडीशन कि यहाँ पे जो फ्लक्स है, it is not a constant but it is a function of temperature. Okay, right? So in summary what we have, इस lecture से क्या आएगा? From summary, what we studied is the energy balance equation is nothing but dou 2t plus q dot by k is 1 by alpha into dou t by dou t. और अगर इसको हम वो करेंगे expand, so this comes as dou 2t by dou x square plus dou 2t by dou y square plus dou 2t by dou z square plus q dot by k is equals to 1 by alpha into dou t by dou t. Now just look at this expression, और let's say कि हम थोड़ा सा simplify करते हैं इसको. Let's say we consider only 1D steady state heat transfer. Now the moment we say 1D, इसका मतलब ये टर्म 0 हो जाएगा, ये टर्म 0 हो जाएगा. Steady state whenever we say, that means this term becomes 0. जैसे फॉर एग्जाम्पल ये है तुम्हारा स्लैब, यहाँ पे टेम्परेचर T1 है, यहाँ पे टेम्परेचर T2 है, एंड इट इज वन डायमेंशनल स्टेडी स्टेट इक्वेशन. तो इसके लिए बिकॉज एरिया क्रॉस सेक्शनल एरिया इज कांस्टेंट एंड वी आर आल्सो सेइंग दैट दिस इज आइसोट्रोपिक सिस्टम. तो इसके लिए जस्ट बाय लुकिंग, इफ यू रिमेंबर दिस एक्सप्रेशन, दिस एक्सप्रेशन, इसको तुम सिंप्लीफाई कर दोगे कि 1D है तो दिस टू डेरिवेटिव्स आर 0 एंड स्टेडी स्टेट है मतलब ये. सो देन यू कैन से दैट dou 2t by dou x square प्लस, और हीट जनरेशन भी 0 है यहाँ पे, प्लस 0 इज इक्वल टू 0, राइट? तो यहाँ से तुमको पता चलेगा कि इसका जो गवर्निंग इक्वेशन है dou 2t by dou x square इज 0, इसका मतलब dou t by dou x इज सम कांस्टेंट, इसका मतलब टेम्परेचर इज C1x plus C2, राइट? तो टेम्परेचर प्रोफाइल इसके अंदर होगी ऐसे लीनियर बिकॉज डेरिवेटिव इज कांस्टेंट, राइट? So these are the takeaways from this expression is very important, which is a takeaway. And in the next class, what we are going to see is using this expression, we are going to solve multiple problems. जैसे ये है, ये वन डायमेंशनल स्टेडी स्टेट स्लैब है, जैसे कॉन्सेंट्रिक सिलेंडर होगा, कॉन्सेंट्रिक सिलेंडर में हाउ डू वी कैरेक्टराइज दिस थिंग्स, राइट? So this is the overall summary of this class, and we'll continue take it from here in the next class. तो किसी को कुछ डाउट है तो you can ask. If anybody is derivation में, what I recommend is ये I will upload this this PDF onto the lecture, and you carefully go through this the way this is derived. ये अगर एक बार if you read it very carefully, you will be able to understand the derivation. And once you remember the able to do derivation, एक बार ये expression you have to remember. Okay, so just do a bit of convince yourself that this in fact comes out वहां से in generalized energy balancing. So if anybody has any question, they can ask. किसी को कुछ डाउट है तो पूछ सकते हो. Anybody has any question? अगर क्वेश्चन नहीं है तो दिस आई विल लीव इट टू यू. ये जो क्वेश्चन है इसका आंसर ये वाला, ये जो डेल है ये तो हमने अभी उसमें डिराइव किया कार्टेशियन कोऑर्डिनेट सिस्टम में. कार्टेशियन कोऑर्डिनेट में डेल टू टी इज नथिंग बट डो टू टी दिस. लेकिन सिलेंडर कोऑर्डिनेट में क्या होगा, स्फेरिकल कोऑर्डिनेट सिस्टम में क्या होगा? सो दैट आई थिंक ट्राई टू फाइंड आउट. वी विल डिस्कस दिस इन द नेक्स्ट क्लास. किसी को कुछ डाउट? इफ नॉट देन वी कैन स्टॉप हियर.
No, sir.
No
doubt?
doubt, sir.
नो
No
डाउट?
doubts.
सबको सब समझ गया?
Yes, sir.
बहुत बार बाप रे, बहुत रिसेप्टिव लोग हैं. नो डाउट्स, एवरीथिंग एकदम सब कुछ समझ गया. बहुत होशियार स्टूडेंट्स है आप तो. ठीक.
सर
अगर
इसमें से एक्चुअली मोस्ट ऑफ क्लास में पढ़े हैं,
अच्छा हो
थोड़ा
चुका है.
भी चल रहा है. यस.
ओके ओके, तो रिकॉल हो रहा है थोड़ा थोड़ा.
यस सर.
Yes, sir.
हाँ, रिकॉल हो रहा है तो अच्छा है.
कौन पढ़ा रहा है हीट ट्रांसफर?
डॉक्टर कन्हैया लाल सर.
एक्चुअली मैं इसलिए पढ़ाया क्योंकि जब मैं बीटेक में था तो हमको ये एक्सप्रेशन पढ़ाया नहीं गया था. हमको बस बोला